Welcome everyone. Today we will learn how to implement the repository pattern using Entity Framework Core in an ASP.NET Core Web API. For this demo, we'll use Docker Desktop to pull an image and to run SQL Server instance as a container. So the first step is to pull the image by running this command. I've already pulled the image, so I'll skip this step. Second step is to run the image by copying this command, paste it in a terminal window, define the password. Let me open Notepad to copy my password and execute. The container is running, so go to Visual Studio to create a new web API. Here I'm using a clean architecture template. If you want to learn about clean architecture, I have a video. I'll provide the link in the description below. Basically, we have the core layer with two projects, the application and the domain, and the infrastructure layer that contains the persistence project and the API. So to connect with the database in the persistence layer, we'll add a NuGet package from Entity Framework Code, install the SQL Server package. To access data from the database in the persistence layer, we'll add a new class called context. This class will inherit from DB context provided by the Entity Framework Core, and the constructor will pass the default DB options to the base class. And here add a DB set from our table that will be the user table, adding a property DB set of type user. This will be our entity. So go to the domain, and in the entities folder add the user class. Define three fields: the ID, the name, and the birth date. So go to the context and import the reference from the user. The context is defined. Now we will register the service in the persistence project by adding a new class called persistence installers. It will be a static class with an extension method to call from the program.cs file called add persistence services using the iService collection interface to register the services, and the iConfiguration interface to access the data from the app-settings.json file called services. Add the DB context and pass the context class, and in the options use SQL Server passing the connection strings that comes from the configuration that get connection string section passing the key. Go to the API and the app-settings.json and define the respective section connection strings. There is an object with the SQL Server key. In the Notepad, I have the connection string for the SQL Server instance that basically contains the data source, that is localhost, and the port, the database name, in this case account. The user ID by default is SA, the password defined, and this flag to trust the local certificate. To copy the key and paste it here. Great, we have the connection with the database, and in order to create the database schema, the account database and the user table, we will use code fast migration. So to do that, open a new terminal window. First of all, go to this article. I provide all the links in the description below. We need to install the Entity Framework 7 CLI to execute commands for Entity Framework. Copy this command and paste it here. I'll remove the version to uninstall all the versions from this tool. So execute. So it's uninstalled, and copy again to install the version that we are using. In this case, the version is the same version for the Entity Framework Code, that SQL Server package, that is 7.0.11. Install the tool. Great, the tool is already installed. In the API, the start project will add a new NuGet package to perform migrations called Entity Framework Core.design. So search in the Browse tab for Entity Framework Core, install the package. Great. So go to the third article, that is a migrations overview, and run the following command to create our first migration using the CLI. So copy this command and open the developer PowerShell command. Let me clear the console and paste the command. First, I'll build a solution to clean all dependencies. And here it's important to specify the project, that is the persistence project that contains the context. So it's the persistence, and reference the CSS project, and also add the S flag that corresponds to the started project. There is clean architecture API. Execute the command. I forgot to register the persistence services, so go to the program.cs file, and here call the extension method add persistence. Okay, let me add the reference to the persistence project, persistence, and here call the method passing the configuration. Great. Now we can run the command to create an initial migration. As you can see in the persistence project, we have the migrations folder that contains the schema for the user table with the ID, name, and birthday. So to create the database and the user table, we need to run another command. So go to the documentation. The second command is this one to create the database and schema. Let me copy, paste it here, define the project and the started project. So the project is the persistence and the started project is the API. Let's execute it. Perfect. The database and the table are created. So close this command window and add the repository to implement the repository pattern. So in the persistence layer, add a class called generic repository. This is the implementation, but in the application layer, we will add in the interface folder the contract that this implementation will use. So define the iGeneric repository. This is a generic implementation, so it will be the type T and add the methods to perform operations. First one is to add a new entity, so it's the task add entity as a parameter. The second one is to get entity based on the ID. The third one is to update an entity, and finally delete an entity. And we're using framework code, so we need to use the save changes method to save all the changes. So I will add a new method called save. Right, go to the implementation general repository in the persistence project and implement the iGeneral repository. Type T and define the constraint that T is a class. Implement the interface and create a constructor to inject the context at a global field. And the third method is to add a new entity, so called context that, okay, this is an asynchronous method, so at the await an async keywords context that add async method passing the entity. For delete, we just call, this is not a asynchronous method, so call context that remove passing the entity. This get implementation is a little bit complicated because we want to discard tracking for our entity. To do that, I'll create a new variable called entity to search for the entity based on the ID. So await and we'll context that find async passing the ID and using the team entity. And here we will verify if the entity is not null to discard tracking. So to do that, call context that entry function passing the entity and change the state of this entity to the detached. The detached, as you can see, the entity is not being tracked by the context, and return the entity. For save method, just call context that save changes async, and finally for update, it's context that update passing the entity. We've defined the implementation of our general repository to test the repository pattern. So now go to the API and create a new controller called user controller to test the repository pattern using CRUD operations. So add the controller and empty API controller, and here define a constructor and pass in the iGeneral repository. But it's important to register the general repository. So in the persistence extension method, add services, add the scope by passing the service type, general repository, and the implementation type, actually the implementation. Great. So now we can use the iGeneral repository in the user controller, in this case, type user, import the reference, and create a new field, the respective HTTP methods. The first one is HTTP post to create a new user. Is in task of type action result to return status code and call the method name as we'll take the user as a parameter. So the user will be the repository that add user. I'm using the, okay, this is a new user. I'm using this new user variable to just return the ID of the new user. So here, save the changes, calling the repository that save method and return an OK status code passing the ID. Go to the item repository. I forgot to return the entity in the add method, so go to the contract and implementation to return the entity by just changing the signature of the method. Great. Go to the user controller and return the ID to get information in the next request. HTTP get task of action result get based on the ID. So user be calling the get method and use the ternary operator here to return a specific status code. The user is null, return a not found status code, otherwise return an OK with the user. The next is a HTTP put to update an user. Update, I will receive an user. I'll check if the user exists. So user exists. There is a repository that get method using the ID and verifying if the is not null. So if the user doesn't exist, return a not found status code. Otherwise, call the update method that is not asynchronous and save the changes and return a no content status code. Finally, in the delete method, it's similar to the update. In this case, we'll pass the ID, check if there is an user. First of all, if user is null, return not found, otherwise delete the user. Save the changes and return a no content status code. That's the implementation of our user controller using CRUD operation. So time to test the repository pattern in this application. So execute project. I have a fetch error. Let me see. Okay, this is not HTTP put, it's HTTP delete. Sorry for copying and pasting. We have the Swagger UI to test the API. So create a new user with the name Paul and the birth date in 2000. The ID is auto-generated, so we don't need to define this field. Execute, and we have the response body that is the ID of the user. So go to the get request, pass the ID to get the information of the user. As you can see, we have all the properties, the name and the birth date. To update the user, pass the ID and update the name and the birth date. In this case, yeah, why not, is updated. So execute the get method again. As you can see, the name and the birth date are updated. And finally, the test the delete request, passing the ID. As you can see, it's success. If we execute again, it returns a not found. It doesn't exist. And in the put as well, you can see not found, so the get not found. So this is a simple API using Entity Framework code, connect with a SQL Server database, applying the repository pattern.